So now we're doing lesson 3, and lesson 3 follows lesson 1 of adding and subtracting polynomials. Then we multiplied them in lesson 2, and now we're going to multiply what we call special cases, and you'll see pretty soon what we're talking about. So I'd like you to open your book to page 146, and just remember that your homework is posted in Schoology, and your teacher will tell you out on Schoology when they want that due. So we're just going to look at a couple problems, and this first one is on page 142. It is example 1A. Page 146. So look at this. So look up here with me for a second. If I have 5 squared, that just means 5 times 5, yes? Okay, well, we're doing the same thing here. I'm just going to write it out twice. 3x minus 4 and 3x minus 4. Now, we learned in lesson 2 how to multiply this. FOIL, distribute twice, use the table. So I'm going to multiply 3x times 3x and get 9x squared. 3x times 4, I get negative 12x. Now, I'm going to multiply negative 4 times x and get a negative 12x. And multiply negative 4 times negative 4 and get positive 16. When I combine like terms, I get 9x squared minus 24x plus 16. So, that's how I can multiply. That is a surefire method. If I ever come up with a problem that looks like this, I can just write it out twice. I can multiply, and I can come up with an answer. So that's how I can find a product. Now this is called a perfect square trinomial, because when I multiply it out, the first term is a perfect square and the last term is a perfect square. And we'll talk about that middle term here pretty soon. And of course it is a trinomial. So I'd like you to try this one. Just write it in your book right beside this one, 1A, and just write this out and do it. Go. So hopefully you wrote it twice, and then you came up with 4x squared plus 28x plus 49. Okay, so that is the way you can do this problem every single time. But we want to also tell you about a shortcut to this. So there is a shortcut to these special cases. That's the reason they're called special cases. So let's just look at this in general. If I have a plus b squared, I can write it out twice, just like what we've been doing. When we multiply it, we get a squared plus, so I'm taking a times a and a times b, ab. Now I take b times a, but I still write it alphabetically, and b times b, and I get b squared. So what we're doing here is we're saying, hey, in general, how do these always work out? Well, we're going to get a squared plus 2ab plus b squared. So every single time we do anything where we start with it as a quantity squared like it is here, quantity means that it's in parentheses and then it's squared, we're always going to get this same pattern. We're going to square the first term, we're going to square the last term, and this middle term, you'll notice, is just the two of them multiplied together, and there's 2 of them. So an a times a b, and then there's 2 of them. So that's going to happen all the time. So if I were to put it into words, what's happening is I square the first term, and when I talk about the first term, this one is the first term, this one is the second term. Okay, so second and first. Square first term. Put it in the first place. Then to get the middle term, this is the one that takes a little work, but not much. You take the first term times the second term times 2. And then to get the last term, you square the last term. So I'm writing it in words, but I want you to see the pattern here, because this happens a lot in upper division math where they just give you, oh, this is a pattern, now you have to apply it. So sometimes it's helpful to say, hey, what's really happening in words? So these are just some really quick words. Okay, let's try it out with those same problems we just did. So I just took those same 2 terms that we just did, and I wrote them again. And if you have room in your book, just put them underneath what you just did, or put them someplace right around them. You have a left-hand column. So we're going to try out what we just did. And we know that it's a squared plus 2ab plus b squared. So in other words, square the first term. So we're going to take 3x and we're going to square it, plus I take the first term times the second term times 2 plus I square the last term. So I get 9x squared plus 12 times 2. Whoops, that's going to be a minus. So that's 12 times 2. So that's going to be negative 24x plus 16. Now, I wouldn't normally write this out because if I'm going to do the shortcut, to write it out does not help. And so that's the reason, personally, I don't think this is really a shortcut. I'm going to show it to you so that you know about it, but for most people, this is not a shortcut to do this. They usually mess it up more than they get it right a lot of times, so I'm not trying to be cynical, but I think it's just as fast sometimes to write it out and multiply twice. But my job is to teach you everything. So let's do this last one. I'm going to square the first term. 4x squared. I'm going to take the first term times the second term times 2. It's 14 times 2, that's 28x. And I'm going to square the last term. Okay, so if I can say it out loud, that will work. Good. Now, this is something I'd never done with this before, which I thought was pretty cool. So what it's saying, let's take 71 squared. We don't know what 71 is squared. Yeah, we could do it on a calculator, but we can also do it another way. We could write this as 70 plus 1 squared. So now what I can do is I can use that pattern. So 70 squared is 4,900 plus 70 times 1 is 70 times 2 is 140 plus 1 squared. And then I could add all that together and I get 5,041. So it's just another way that I can multiply it out. And again, my job is to show you this, and it really is kind of cool. Now we're going to go to the other special product. There's exactly 2. So look at 2a. It's in your book. I want you to multiply that using what you learned in lesson 2. So when you multiply this, you're going to get 4x squared plus 8x minus 16. When I combine like terms, I get 4x squared minus 16. So this is called a difference of squares. Difference meaning subtraction, squares meaning there are perfect squares. And notice I multiply these two binomials and I come up with a binomial, not a trinomial like we a lot of times do. Okay, this is another special case. So try the next one right over here. And if you remember, save some space because guess what? There's also a shortcut to this one. And this shortcut you might actually use. Okay, so try that second one, go. And you get 9x squared minus 24x plus 24x minus 64. Again, your middle terms drop out, so you get 9x squared minus 64 because I have two perfect squares connected by subtraction. Okay, let's look at the shortcut. So the shortcut, look at when we multiply it out, we get a squared minus ab plus ab minus b squared. The middle terms always drop out, so all we have is a squared minus b squared. So what's happening here is when I have the exact same term, so I have an a and a b and a b, but my signs are opposite. When my signs are opposite, this shortcut works. And look at what this shortcut is. If you were to write in words, look at that. I square the first term. I put a minus sign in between. And I square the last term. And that's all you do. And this is one that I can see actually using. So let's go back to those problems in your book again and use the shortcut. So the first thing is I notice that it's the same terms, and I have opposite signs. So I'm going to square the first term, 4x squared, minus square the last term. This truly is a shortcut. Go, do that second one. And you're done, right? Because you have 9x squared minus 64. This one is a shortcut. So this one is really cool as far as I'm concerned on how this one works. And we're going to multiply these two numbers. So when we have different numbers like this, what we have to realize is that we have to, in parentheses, rewrite it. And we have to have the same number here and here, and the same number here and here. And if we're going to use a shortcut, one has to be a plus and one has to be a minus. So how can I write 56 and 44 with the same two numbers? Well, I can put a 50 plus 6, and I can put a 50 minus 6. Whoops, one has to be a minus. Okay, So I can take 50 plus 6 and 50 minus 6. The other big key is I want one of my numbers to end in a 0. Okay, so here we go. I'm going to square the first term. 5 squared is 25, and you have 2 zeros, minus 6 squared, which is 36, which for me is the easy part. Now I have to subtract. We know I don't do that so well. Okay, so that's going to be 9. Let's see if I can get it. So what we're finding out is that's 2,464. So it really is kind of cool. I've never done that before in teaching all the years I have, and I thought that was really pretty fascinating. So pretty cool. Fairly typical type of problem. So again, we're going to talk about the outside, the whole outside, like what you did. If I look at the whole outside of something, then I'm going to look at the inside, and I'm going to find out different things. Okay, so the square pixelated image is placed inside a border that is 4 pixels wide. So what they're saying here is this right here is 4 pixels wide. Okay, so all of this is 4 pixels wide. So that means this in here, this square inside is x. So, if the area of the border of the image is 704, so they're saying the whole thing, what is 704, then what is the area of the image? So again, what we're looking at is the inside area is going to be x squared. The outside area is going to be x plus 4 quantity squared. Okay, so the inside area is x squared because each side is the same. Outside is x plus 4. Then what it says, if the area of the border is 704, so if everything together is 704, okay, so what we're doing here is that we want to find out then what is just the outside part. I misspoke. I apologize. What this is actually saying is the area of the border is 704. So that means I'm going to have to take the entire thing, the outside minus the inside to get the whole outside, which is 704. So I'm going to have to take the outside minus the inside. Okay, so the outside is x plus 4, and if we want to, we can just multiply that right up here. We can use the shortcut, or again, you can write it out twice. It does not matter which one you use. No matter what you do, if I do the shortcut, I'm going to talk you through it again. Square the first term. Take the first term times the second term times 2, and square the last term. So we're going to take that outside part, x squared plus 8x plus 16. We're going to subtract the inside part, which is x squared, and that's going to be 704. Now, the only way we can actually do this is because our squared terms will cancel out. So we get 8x plus 16 is equal to 704, and now we're going to subtract 704 minus 16. So 8x is equal to 688. Divide by 8, and we get x is equal to 86. Okay, what is the area of the image? So what we're doing here is we're finding this right here, and it says that each side is 86. So in order to find that area, I'm going to have to take 86 and square it. Okay, now, if I wanted to without a calculator, I could do 80 plus 6 and 80 plus 6. So that'd be 6,400 plus 480 times 2. So see, I don't always know when that's convenient. I'm just going to use my calculator right now, and I'm going to square it. So I get 7,396. Pause. Which totally makes sense. At first I was like, wait a second, 704, how can I get 7,396? 704 is just the red part around, so it's not going to be very big. Whereas that 700, that's going to be all the picture on the inside. Okay, good. So this page is just a summary of what we just learned. So we can talk about it in words. We can see the shortcuts right here. Okay, so we have the shortcut. And remember, we also can just multiply it out. So if you wanted, this is just not the shortcut. These two are not the shortcut. I don't care which one you use. Make sure you can multiply special cases. Now we're on page 148 with the essential questions and the review. And it says, what patterns are the same in the product of the square of a binomial and the product of a sum of a difference? I liked their answer. So if it's the product of the square, so this is a perfect square trinomial, the middle term is always twice the product of A and B, while the product for the sum and difference, Okay, the middle term is always canceled out, leaving just the a and the b. So we have the difference of squares is what we're talking about here. This is a perfect square trinomial, which is a trinomial, so it has to have a middle term. Question number 2, find the error analysis. Kennedy multiplies this and gets this answer. Well, do you see the error? Well, one of the first things you might notice is that, see how my signs, my terms are the same and my signs are different? When this happens, this shortcut is the easy one. We know our middle terms are going to cancel. They're going to add to 0. They're going to drop out. So it can't be a trinomial. You can't have a middle term. Okay? So no middle term possible. No middle term possible. Okay? Then the product x plus 6 and x minus 6 is equivalent to an expression that we call the difference of squares, which we already talked about. Explain why the term difference of squares is appropriate. Well, difference means subtraction, and we have 2 squares. It's honestly just called difference of squares, but maybe I'm wrong. Okay, number 4. Explain why the product of 2 binomials in this form is a binomial instead of a trinomial. It's a binomial because your middle term is going to drop out. We kind of already talked about that up here in 2. So your middle term is going to drop out here on 4. So now we're just going to practice a couple problems, and I don't care what method you use. You can multiply it out, writing it twice and then multiplying it out, or you can use a shortcut. Try one of each maybe. So what I'm saying is you can start by just writing it out twice and multiplying it and get the answer, or you can use a shortcut. I'm going to let you decide. Go. So make sure you take some time to try these to see if you're getting them or not. Because if you're not getting the same answer, that means you might need to go back and do it again. So for this one, x squared minus 14x plus 49. 4x squared plus 20x plus 25. What did I do? I squared the first term. I take the first term times the second term times 2, and then I squared the last term. Okay, that's the shortcut that I'm using, but I could have written them out and got the same answer. If memorization is not your thing, just write it out. Now we're going to do the other one. This shortcut I think is valuable. Notice that the terms are exactly the same, x and x, 4 and 4. My signs have to be opposite. When I do this, I square the first term minus the square of the last term. Square the first term minus the square of the last term. That shortcut I think is worth it. Added a problem in here, and what I would suggest is use the space for 3 or 4 because we didn't write much if we did write anything at all. So use this, draw this picture, pause yours right now, and write this picture down. This picture, I'm going to tell you where it came from as you're writing it down. This picture came from one of the problems in the book, so it might be exactly like a problem you might have in homework, or it might be similar to it. I don't even care if it's an assignment. This is something that shows up all the time and we need to know how to do it. So what we have right here is that we have a square, okay? So we have our square right here, and we are told with this square that each side is x by 6. So the area of the outside, or the square, and I always like to call them outside and inside, is going to be equal to x plus 6 quantity squared. The blue one, the inside, and here it is blue in my picture, is going to be x squared because I just take a side and square it. But what they want to find is they want us to find these triangles. What is the area of all these triangles, this outside stuff? You will see we've seen problems like this before. We're going to take and find the outside. We're going to subtract off the inside. The same thing we're doing here. We're taking the outside and we're subtracting off the inside. Okay, so what is the outside? The outside, and that's what they're asking us to represent here, is x plus 6. And we're going to subtract off the inside, which is x squared. Now don't leave it like that. When it says write an expression, simplify it. So let's multiply this one out. You can write it out twice, or you can just use a shortcut. So x squared, x times 6 times 2 is 12x plus 36 minus x squared. Notice my x squared terms drop off, so I get 12x plus 36. Okay, just wanted to show you that one as another example of that same type where we have the outside minus the inside. It's very typical. These are also pretty cool, and I'm just going to show them to you. Not sure what the assignment will have in it, but this is always better to have too much information than not enough. So it wants us to find the area of this and either use the square of a binomial or else use a difference of squares. So we're going to have 54. Just look at the problem. It's going to be 54 squared. So we're going to have the exact same thing. So it's going to be 50 plus 4, 50 plus, oh, sorry, I don't need to write that. 50 plus 4 quantity squared. Wow, I'm just doing all kinds of fun things now. Okay. So I'm going to get 50 squared. So I'm going to square the first term. Take the first times the second, so that'd be 20 plus another 0, and then square the last term. Now, because I'm a person who doesn't add and subtract well, this one's the hardest type for me. So 6 went, oh, but look at this nice addition. It does work out really kind of cool. Okay, and that'd be 2,716 centimeters squared. So that's a handy thing to have. And now we're going to find the area here, which is length times width. So we're going to take 24 times 36. And these are awesome as long as they're numbers that actually are something you can get them to be the same number. So obviously we have two different numbers. We're not squaring it. So we have to find a number that either probably going to subtract. The smaller one we're going to have to subtract, and the larger one we're going to add. What are two numbers that can be the same? Well, if I take 30 minus 6 and 30 plus 6, I can do it. So this is great. However, it limits you as to, what you can actually put in for numbers. So square the first term, 900 minus square the last term. So I'm going to subtract. And in our day now where everybody has a calculator, this is not as cool. But in its time, I'm sure it was. I don't even remember learning this, but it's cool. So 864 inches squared. Good. Now we've covered everything. You should be good for your homework. Go out to Schoology and get started on that. Thank you so much. If you have questions, you know where to find us.